Welcome for the session of bending and shear stress. In this session, we are discussing the concept of moment of inertia, then moment of inertia of some standard section like circular and rectangular section, then why we are using parallel axis theorem and numerical based on I and T section. So let us go for the moment of inertia. Moment of inertia is expressed by the body resisting the angular acceleration. It is the sum of product of mass of every particle with its square of the distance from the axis of rotation. It is denoted by letter I, where Ix is the moment of inertia along horizontal axis, whereas Iyy is the moment of inertia about vertical axis must be passing through the center of object. Then we are going for the moment of inertia of some standard section, like here rectangle, hollow rectangle, circle and hollow circle. Let us move for rectangle. As we see, rectangle of side B and D is given. Area of this rectangle is B into D, which is in mm square, whereas the value of I is BD cube by 12 along XX axis. Similarly, for hollow rectangular section, B and D are the extreme sides of this hollow rectangle, and small b and d are the interior side of hollow rectangle. So area of this is capital BD minus small bd, and Ixx, that is BD cube minus small bd cube divided by 12. Similarly, for circle of diameter small d, area of circle is pi by 4 into d square, whereas the value of Ixx as well as Iyy is pi by 64 into d raised to 4. For hollow circular section of capital D as the exterior diameter and small d as the interior, area of this circle is pi by 4 into capital D square minus small d square, and the value of moment of inertia is pi by 64 into d raised to 4 minus small d raised to 4. So these are the some standard sections which we have discussed over here. Let us go for the parallel axis theorem. Now we will learn why to use the parallel axis theorem. As we seen, parallel axis theorem we will use when we will not find a standard section. Moment of inertia of an object about an axis parallel to the central axis is the sum of moment of inertia about central axis and the product of area of object and the square of the distance between two parallel axes. Now let us discuss the moment of inertia of an object about an axis, that is AB axis over here, which is parallel to the central axis. So we need to draw the central axis over here. For that purpose we are drawing a circle and we are passing one line that is through the center, so we can call this as a central axis. It is the sum of moment of inertia of central axis, that is Ig, and the product of area and the square of the distance between these two axes. So here area of circle is pi by 4 into d square, and if you see the distance between two parallel axes, that is AB axis and this Ig axis, is h. So it is nothing but a into h square. Is this amazing to learn the parallel axis theorem over here? So we will meet with numericals based on I and T section in next session. Thank you.